Hello, I'm Warren Powell. This is part two of the Universal Modeling Framework for Sequential Decisions. This is the part on framing the problem, and this is the most critical part of the series. So, framing the problem. Let's say I have a physical problem, and I'd like to use the computer to help me make decisions. And the standard way that we approach this is we first have to build a mathematical model, and usually that means trotting out some analytical type who can take the real problem and put it into math so that we can put it on the computer. Now, the challenge with this standard approach, which is widely used today, is that analytics comes in different flavors. I might have machine learning. There's a whole field of people learning machine learning and statistical modeling. Monte Carlo simulations, the neural nets. So that's a part of machine learning, but increasingly there's people just specialized in neural nets and the large language models. We have decision trees taught to many business students. Math programming, very popular in engineering, widely used in business. This is a very specific language. And by the way, lower right-hand corner, stochastic search. There's my 7 choices, and I have the uncertainties about that, and I have to do trial and error. Now, each of these are very distinct fields. People are trained in this. They can get PhDs in this. They learn how to come out solving problems with this. And they look at problems through the lens of their training. I call this expertise filtering, where they will look at a problem if they have good training in math programming, that they will look at a problem through the lens of the types of problems that math programming is useful for. I've got a new vision. Now, let's start in the upper left-hand corner of a business problem. There's a group of people discussing a problem. Now, maybe this is a health problem or manufacturing, but let's just stay with the generic business problem. Now, the upper right-hand corner is a skill set that I'm trying to develop, and this talk is aimed at the group of students. These are students at the Rutgers program for supply chain management. Now, these are very bright students. They're not analytical. They don't code, but they're very good at using tools to solve business problems. I think this is the ideal community for a step that I'm referring to as framing the problem, and I will talk about that in this section of my talk. Now, framing the problem involves asking and answering 3 questions, and I think there's going to be many problems where the simple process of going through this framing that involves no math, and it doesn't even require any data, may end up helping to solve the problem. But when it doesn't, that's when we're going to turn to analytics. We'll get to that in part 3 of the talk. And there's very modest analytics. However, this would be where you turn over to somebody trained in analytics and using computers, a data scientist, for example, who then might say, okay, I can implement this in a spreadsheet or maybe a fancier computer model. Now, the beginnings of framing the problem starts with this one slide. So we have our opening question. If you want to run a better supply chain or anything, you have to make better decisions. And I take that as sort of everybody nods and says, okay, I understand that. The path to improvement starts by answering 3 questions. What are your performance metrics? What decisions do you have to make and who makes them? And what are your sources of uncertainty? So I would like to encourage everybody to go to the URL at the bottom, tinyurl.com, doing better PPT, and hit that, and you can download this slide. This is the defining slide of framing in the process that I use. Now, before we really get started, I want to address the issue of when we talk about the problem, what do we mean by the problem? I tend to find that problems come in 2 broad flavors that I call metric-focused problems and decision-focused problems. Now, metrics-focused problems is where we know what we want to accomplish. We want to maximize the stock price or reduce costs, or I want to increase the strength of a material or minimize overdose deaths. Now, but I don't necessarily know what the decisions are. I have to work to figure those out. Now, the decision-focused problems are where I do know the decision. I need to locate warehouses or route trucks or set prices. However, the metrics still have to be defined. Now, obviously, there's some interplay between the two. I'm going to start off by assuming that we need to address the metric-focused problems. I just want to acknowledge that there are problems where we either start with metrics or start with decisions, but eventually you have to describe both. So let's start with metrics. Now, metrics, also known as KPIs in businesses. Businesses have, I don't know, hundreds and hundreds of KPIs. They have different KPIs for every position. Now, I enjoy the work of Laura Césaire. She's a very bright influencer on supply chain management. She has this book where she argues that there's two key metrics. So she looks at these messy piles of metrics. Now, she's a little bit more focused on the C-suite, and she has two favorite metrics. One is the operating margin or earnings per share, something indicating profitability, and the other is inventory turns. And she says these are the two core metrics that help you understand how well a company is doing. Now, I understand that we need many metrics, but I would like to prioritize using a pyramid, where at the top of the pyramid that's the top dog. That's the metric that you're focusing on, but it depends on where you are in the company. So if I'm working at a corporate level, boy, and it's a publicly traded company, I'm focused on the stock price. Or if it's private, it's maybe the profitability. But maybe I'm down in a manufacturing plant where I don't know anything about the stock price. I really just know about the unit cost, and that's the metric that I can impact. My activities don't really impact the stock price. Now, these metrics, these pyramids can be built around any activity. And so what I encourage you to do is whatever you're working on at whatever level in the organization, focus on the metric that is of greatest interest to you. Now, there are many pyramids in larger companies, and managers at one level may even set the metrics of the lower levels, and that ends up actually being an important decision. Now, there are many, many metrics, but you can organize them by categories of metrics. Right now, I'm up to 7 categories of metrics. And then when you go to measure the metrics, you start off by measuring how well you're doing on average or over time. But you also have to recognize that occasionally there's these hiccups. And these hiccups, I call them risk events. These are events that are not captured by your averages. They're not properly reflected. You can have a down month, and that's captured by the averages. But if you have a catastrophic month that maybe sends ripples through Wall Street or your customers, that's not really captured by the average. So risk events are described in English, and then risk metrics are where you quantify the risk events, and they're not necessarily in dollar denominations. Now, performance metrics, I like to describe them in 3 styles. Objectives to be minimized or maximized. Limits, which are metrics where you don't want to go above or below a certain level. And then targets, where I might go above or below, but I'm really trying to hit a particular value. And the closer I am to the value, the happier I am. Now, the book, The Goal, this is probably one of the most popular business books ever written. The title, The Goal, is specifically addressing the fact that there's a problem of metrics. So the story is about a factory, and it's being threatened with being closed down because it's not profitable. But the factory doesn't use profit as a metric. It uses other statistics like, how well are we using this expensive piece of equipment? And what the goal is about is saying, hey, you're focusing on the wrong metric, which, by the way, is a decision. Okay? And I want to highlight that choosing the metrics is an important decision. So let's go to decisions. Now, decisions is an interesting concept. We've been talking about decisions since the days of Aristotle, Socrates, and Plato over 2,000 years ago. This is a handful of great names who've done really seminal thinking. George Danzig is there with linear programming, and Richard Bellman with dynamic programming. Daniel Kahneman at the end is one of my former colleagues at Princeton who thought about how humans make decisions. And in this entire history of these great thinkers thinking about decisions, I couldn't find any evidence that any of them had actually defined a decision. So if you go to the academic, the optimization communities, on the left we have all these books on deterministic optimization. They all use a particular notation where X is the decision. And if you go to these people and say, what's your decision? Their answer would be, well, X. Now, these books don't deal with uncertainty. On the right are all the books that do deal with uncertainty. Most of these are mathematically fairly sophisticated. They have all kinds of complicated equations, but the decision is always X, or maybe it's action A or control U, but it's always a variable. It's always like, oh, there's my decision. And they don't actually get to the point of saying, yes, but Before you define X or A or U, you have to say what it is in English, and none of these books ever do that. Now, let me start with a simple observation. So there's three flavors of information from the perspective of how that changes over time. So if I'm at time t, there's what I know. So that's a snapshot. You could call it the state of knowledge. And then the state of knowledge changes in part because of information that I control. Okay, that I control as a controller, I can create or control information. And then there's new information that just happens to me from outside my system. So clearly, number two, those are the decisions. That's where I'm controlling that. And so of these three flavors, number two is the flavor that's a decision. I give it the definition, an endogenously controllable information class. But plain English, we could say it's something we control. You could call it a choice among a set of actions. Now, if you go into a company and say, well, what decisions do you make? I've got to warn you, you're going to get blank stares because people don't know how to answer that question, and it's really quite funny. Now, one thing just to be aware of is that we use a number of different words for decision in the English language. And sometimes people will not know it because they just don't use that word. And so you have to be aware that language is an issue here. Now, much more relevant is I've so far identified 7 different types of decisions. And I've found that when I work with communities, especially the algorithms people, the math people who want the computer to solve problems, and they say X, what they really mean is a type 1 decision, okay? The decision tree people need type 2, and the bandit people or stochastic search need type 3, and they just think in terms of those types of decisions because that's how they're trained. Now, decisions are made in different time frames. We have to understand it's an important characteristic of decisions. We have real time, we have tactical planning, we have strategic planning decisions. And decisions are also made by different people at all different levels in the organization, or your customers, or your competitors, or you. Now, this is one of my favorite slides. I was invited to a workshop, an academic workshop at Amazon many years ago. And then they gave us a tour of a fulfillment center. And I was already getting into this mode of thinking about decisions. And as I walked around the fulfillment center, I would find myself saying, okay, where are the decisions? And what clearly emerged is there's a group of decisions that were design decisions. Those decisions were made when they built the factory. But then there's a bunch of other operational decisions that are made on a minute-by-minute or hourly or daily basis. Okay? Now, these types of decisions arise in many settings. Maybe I'm trying to improve a hospital, or maybe I'm trying to help with drug development or improve a forest. Now, what I like to start getting people to do is to walk around with your decision book. Now, this is a book you can get from Amazon. It's a blank book with blank pages because we need people who are trained in their ability to look at human processes, operational problems, and to identify decisions, as well as the metrics and the uncertainties. And this is something that has to be done by observation. A computer can't do this. But I also find that when I ask people to do it, they don't know how. And so this is something that requires training. The basic concepts aren't that hard, but applying them is surprisingly difficult. It reminds me of this famous commercial from the 1970s on a new product then called V8 tomato juice or V8 vegetable juice. And it started with a video where they would feature people walking around and possibly drinking a soda. And as they're drinking the soda, they have sort of this eureka moment of, oh my gosh, I could have had a V8. And this became the I could have had a V8 commercial. What this line of commercials was doing was trying to make people realize that they were making a decision. When they just pick up that soda, they could have picked up something else. This is a skill that I think not only can be taught, but needs to be taught in almost any domain of life. Now, decisions. What do decisions do? Well, obviously there are decisions that impact the physical world, but there's also decisions that impact the financial world. There's a more subtle class of decisions that change information. Marketing and advertising, setting a performance target are all informational decisions. Now, what we're going to do uh, when we start identifying decisions is what we're going to do is we're going to list all the metrics from the most important metrics down to the least important metrics, and then we're going to list our decisions. Now, this spreadsheet, which you can download, the link is there at the bottom, I call these interaction matrices. And again, no data here, no algorithms or anything fancy. This is just domain knowledge. So this cannot be done by the math guy. This has to be done by people familiar with the problem. And you go through and you enter H if that decision has a high impact on that metric, M for medium, L for low, N for none. The spreadsheet will light up, and if you put in a H, that cell will turn red. And then when you're done this, and it's not a very time-consuming exercise, but it does require domain knowledge. What you then want to do is to identify the decisions with the highest impact on the most important metrics. Okay? And that's how we sort down, because if you just sit and say, what are all the decisions, you can really end up with quite a long list. Now, uncertainties. Oh, uncertainties are complicated and poorly understood. In the supply chain world, there's endless books about uncertainties. You can have, but what they do is they have these books that emphasize risk or resilience, and these become buzz phrases that people go running after. It's sort of eye candy. By the way, I do particularly like the book by Schlegel and Trent, their Supply Chain Risk Management. It's quite a nice book. It goes a little bit step beyond just listing sources of risk. My contribution is I have a chapter in one of my books where I identify 12 classes of uncertainty. Now, these classes have nothing to do with any problem domain. It has everything to do with modeling. So it applies to any problem. Now, what you have to do is list these 12 classes of uncertainty and then apply them to whatever your problem domain. So if you're in a supply chain setting, I took each of the 12 classes and then found one example, because often you're going to have multiple examples when you have something complicated like a supply chain. Like if I was talking about how to model playing chess, I would only have one form of uncertainty. But when you do something complicated like supply chain, or maybe you're managing the power grid, there will be a whole bunch of others, or public health. Now, what we're doing with these 12 classes of uncertainty is we're using them to help prod your imagination to think about uncertainty. There's some overlap, and that's fine. The key thing is to get as long a list of types of uncertainties. Now, after that, we then also have to think about the behavior of each type of uncertainty. You can have uncertainties that work on an hourly time frame. There can be bursts and spikes, but maybe you have periodic shifts, regional events, systemic events, black swan events, and maybe contingencies that have never happened before, but maybe they will happen. Now, what we're going to do is play the same exercise that we did with decisions with our interaction matrix, where we list the performance metrics along the top from most important to least important, and then the sources of uncertainty, just list them in any old order. Now, fill in the cells with a high, medium, low, or none impact. What we then want to do is identify the uncertainties that have the highest impact on the most important metrics. So finally, we're going to, let me illustrate all this with a seemingly simple supply chain problem. I've got a warehouse in Atlanta in the southeastern United States. I'm getting product from Asia. It takes several months to order. Now, I have to think about the fact that there may be storms in that time period that I don't know about, but they might come up. And I also have other decisions, like doing a rush order by air freighting product in to meet a shortage. Now, when we teach about this, I have this shelf full of books, and these are what I call my favorite books. And I've organized them in 3 categories. Toward the left are the heavy theory books. These are the heavy math books. These are primarily entertainment for PhDs. They're exclusively using stylized models where you can do elegant math. I'm not really sure what the students are learning from these, but it's fun. I do happen to enjoy this type of material. Now, the books in the middle, these are the books that are most widely used in either industrial engineering or business schools. They're master's level, and they have some analytics, But generally, it's watered down mathematics for simplified models, especially when it deals with decisions and uncertainty, as in any inventory problems. Now, again, these are books I like, but I don't. Uh, I have problems with the use of all the watered down models. Now, the books I happen to like the most are the ones farthest to the right. These books have no math, but they all use analytical thinking. Okay, these are smart people. They're not writing fluff pieces, and in fact, one book, Introduction to Supply Chain by Johannes Vermeerl, this is a challenging read, even though there isn't a hint of mathematics. The book, The Goal, is very famous. This is just a fantastic book. Laura Cesaire's book says, none of these books, however, shows how to properly model a real inventory problem. Now, you would think we've been studying inventory problems since the 1950s. None of these books will show you how to properly model an inventory problem. So here's a generic model that you can find in a number of these books. The standard textbook, when to order inventory, how much to order, who to order from, safety stocks. Business schools love teaching this material. It's very basic. Now, they ignore the fact that real inventory problems look like this. You can have 8-week times for the product to arrive, all different types of uncertainties, different actions you can take, downstream decisions. Now, we have to be aware that when we study supply chains, there's a lot more to supply chain than just inventory management. All of these are topics that arise in supply chains. All of these have decisions that are made under uncertainty. So this is learning how to plan inventories shouldn't just be something that ends up solving the inventory problem. We should be learning how to solve all of these problems. And my framing process does apply to all of these problems. Now, metrics. Let's say we're at the corporate level. Okay, so I can be working at any level of the organization, but let's say I'm at the corporate level, and let's say my top metric is operating margin, and then I have other metrics that go further down. Now, this is where, by defining the metrics, this is where you really anchor the problem. So maybe I'm not focused on operating margin, but whatever it is, this is something where a domain expert has to say, these are the metrics, this is what's important to my problem. Now, decisions. So I have another URL, tinyurl.com, PAL Inventory Decisions. You can download the spreadsheet. I have about 20 different types of decisions made on all different timescales that impact physical, financial, and informational resources. Once again, I can't deal with all of these decisions. I want to use my interaction matrix to identify the ones that have the highest impact on the most important metrics. And then uncertainties. Again, we have uncertainties working at very different time scales. They can impact physical, financial, and informational resources. Also, this is a long list of uncertainties. I may not want to deal with all of them, but once again, I can use my interaction matrix to highlight the uncertainties that have the highest impact on the most important metrics. Thank you. This is the end of part 2. I hope to see you in part 3.